And good morning. So we'll continue with the third method in our module 2, which is Gauss-Seidel method. And before that, I just want to go over a few general announcements. I've been updating the syllabus and reposting it after every lecture and try to add comments and section numbers to keep it easy for you to follow and when you prepare for your exams. For each method, I've indicated which section number in the textbook to refer to and the recording wherever it is available. I think so far we haven't missed any recording, so that's good. Um, your quiz 2, that is the second quiz on module 2, is coming up on Tuesday, which will have 2 problems as before, covering 3 methods. So you're supposed to prepare and you don't know what you're going to get, 2 out of 3. Okay. The homework 1 programming exercise is due as well on Tuesday at the start of class. So please bring it as a paper copy and submit. Okay. It should have a printout. I mean, it should have the handwritten notes to whatever you are trying to explain and a copy of your computer code as well as a copy of the output. Okay, whatever you are trying to print out from your code. And after the quiz, we'll do some programming related to Gauss-Seidel method using MATLAB. That is also planned for Tuesday. And from Thursday onwards, for the next 4 lectures, I'll be discussing probability and statistics, for which the course material is not your regular textbook. I've posted a handout which you can get by going to Canvas. And where is it? So if you go to files, you can see the probability and statistics handout. That's what you're supposed to follow from next Thursday. Okay. Other than that, for your quiz preparation, I've posted a mock quiz. So if you go under mock quiz folder, you can see quiz 2 mock, which is right here. And the format, like I said, is to give you a system of equations and ask you to solve it using 2 methods. Here in the mock, I've given Cramer's rule and Gauss-Seidel method. So today we're going to see Gauss-Seidel. Okay. What I also suggest is if you go to the syllabus, I have given links to the prior semester's course materials. You might find some useful examples there if you go back and look at those folders, which I encourage you to do. Okay. Each time I try to build these files and we end up creating these files which you can use. Any questions? Yeah. Solutions. We are going to discuss it today. Good. Yeah. Any other question? Okay. So I'm going to stop my screen share. I can come back to recording mode. I don't need this for a while. All right. So what did we do last time? We looked at solutions to equations of the form ax equal to b, or a11x plus a12y 13z equal to b1, a21x plus a22y plus a23z equals b2, a31x plus a32y plus a33z equal to b3. And we saw 2 methods. One, Cramer's rule, which is based on determinants. And the second, called Gauss elimination, which involves elimination and back substitution. So these are the 2 methods that we saw. The third in our list is called Gauss-Seidel iteration. This is what we are going to focus today. Gauss-Seidel iteration is a method that relies on, you take this system of equations, take the first equation, okay? Just take the first equation rewrite equation 1 as a formula to calculate x. So I would write it as x equals b1 minus a12y minus a13z divided by a11. Of course, we require that a11 is in 0. Because if a11 is 0, then this doesn't make sense to write it this way. Okay. And then similarly, we rewrite 2 for y. That would be y equals b2. You can do this. A 21x plus a 23z divided by a22. Again, assuming a22 is not 0. Lastly, rewrite 3 for z as z equals b3 minus a31x plus a32y divided by a33, assuming a33 is not 0. Okay, so you've written it this way. If you were to take the first equation and compute x using the first equation, is that possible? What do you need to do in order to get x? You need to know y and z, right? You don't know y and z, that's why you're doing the whole thing. So this method gets its name from the word starting with iteration. We start iterating by step 1. Step 1. Assume guess values for x, y, and z. It can be anything. You could just choose, let's say, x equal to 0, x equal to y equal to 0. Say, you can guess anything. You can say 1, 3, 4, 5, minus 1, whatever you like. You can use it as the guess value. We start with 0 because it's really simple to do that. Okay, so take a pause. I'll give you time to write. Listen. If you're done writing up to here, stop. Just look up, listen. Okay. So you've assumed some guess values for x, y, and z. Step 2, use equation 1 to compute x. So let's say I start with the guess value of y and z. I can use that to get x equals, in this case, b1 over a11. Okay, don't bother writing. I'll give you time. Okay, so you get an updated value of x, value of x. So now, when you move to equation 2, which is for y, instead of using your initial guess for x, use the updated value, and z is still your initial guess. So you can then use equation 2 to get y with updated value of x and the guess value of Z. So whenever the latest available value or whatever the latest available value is for X, Y, and Z, use them and do this sequentially. When you move to Z, X has already been updated once, Y has been updated once, use those values to get Z, and then you repeat the loop. So when you go back to the next iteration, Y and Z have been updated once, use those, get X, get Y, get Z, and you can keep on doing this iteration. When do you stop? When to stop?
Yeah, when you have all three.
You would have all three after each iteration, but my question is, how many iterations should you keep pursuing?
Values are very minimal between, like,
So to give you like a more relatable example, if you are in the shop polishing something, suppose you have to grind it down to a very smooth or some kind of roughness, how do you intuitively start?
10.
No. Be quantitative. Shiny is not a quantitative issue. When you are given a part to polish and a profilometer which gives you the surface roughness. Say if you polish for 5 minutes and then you check the surface profile, you get a certain roughness. And you do this every 5 minutes. You polish for 5 minutes, check, polish, check. When do you stop polishing? Intuitively.
The values would be very minimal.
When the benefit to the cost stop changing, that is, there is no more additional benefit for the work that you put in. That's in every situation that's true, right? You are polishing it, you are checking the surface roughness. If the surface doesn't change after, let's say, the 10th time you polish this, the 11th, 12th, 13th, 15th time don't matter. That's when you stop at 10 or 11. Similar thought, you do this iteration once. That is, once means get X, Y, and Z. That is one iteration. You do this twice, thrice, and so on. After the 14th iteration and 15th iteration, if there isn't much difference, you can stop. Right? That's the idea. So if I call so I'm going to okay, I need to keep this, but I'll erase this. I'm going to continue here. Step 4, iterate until a residue, which I'm putting within quotes, goes or stays above a certain tolerance, which is usually subjective. Which is usually depending on the context. And how do you define this residue? Suppose if you do this once, let us say that is iteration I, the next iteration is I plus 1. Okay. So you would start your guessing process, which we will number as I equal to 0. 0 is the starting guess. You do this exercise once, you get the first iteration. Twice, thrice, and so on. So you can write xi plus 1 minus xi absolute value. What is this? This is the increment, or not increment, I should say. This is the magnitude of the change in x between successive iterations. Magnitude of the change in x between successive iterations. Maybe I'll let you catch up. Okay. Similarly, you can write absolute value of yi plus 1 minus yi and absolute value of zi plus 1 minus zi. Is anybody checking out the YouTube recordings? Is the clarity okay? Okay, good. Have we all written up to here? Yeah? No?
One for it now.
Okay, so I'll give you 30 seconds. Here, use equation 2 to get y with updated x and guess value of z. Okay, so I'm going to say calculate residue as follows. Residue after the ith iteration or after the ith, never mind. Residue is square root of xi plus 1 minus xi plus yi plus 1 minus yi plus zi plus 1 minus zi squared. So I define my residue like this, which is the sum of the squares of the difference in change between each variable between successive iterations. And I would stop when my residue stops changing. Like my residue has gotten very small because the XYZ values don't change anymore. I will stop, for example, if residue goes below, let's say 10 power minus 3, or like a tolerance that is say 10 power minus 3, then stop. Example. This right here, these whatever is on the board is your cheat sheet for Gauss-Seidel method. We are now going to do an example and then do this in Excel. Can I erase this side? Yeah. All right, so now I'm going to discuss the problem that I've given as the mock quiz problem. So you would have a solution to that. I can read out the problem to you. Y plus 7z equals 25.5. Y plus 7z equals 25.5. Phi x plus y equals 0. Phi x 1 0. x plus 6y plus z equal to minus 10.5. So before I start, I'll give you a moment to think about this and think about how you rearrange this to get equations for x, y, and z. Take a minute, just think. Okay. Okay. So again, take a break from writing. Take a break. Okay, let's talk. Here is the system of equations in general notation. And if you invert them for x, y, and z, you get three expressions. If you are going to use the first equation to calculate x, we require that a11 should not be 0. But the way it is written here, we have a problem because the first expression is 0 times, first equation is 0 times x and then 0 times z. Can we still use the first equation to get x? No, right? Because the coefficient is 0, it wouldn't make sense to divide by 0. So if you do this as written, you would run into a problem. Well, this is just three equations. Nobody is prohibiting you from rearranging them or rewriting them or reordering them. So you want, first thing that you want to note down is if A11 or I'll write it as if the coefficient of x is 0, then obviously, I'll put it in parentheses, obviously that equation cannot be used to calculate x. That should be obvious to you. So the first equation is not a good candidate for x, but it could be a good candidate for y or z. Same thing about the second equation, not a good candidate for x and, I'm sorry, good candidate for x or y, maybe, but definitely not for z. Okay? So by elimination, this can't work for z, this can't work for x. Okay? You're good with me so far? Now, let us rearrange this. Let us reorder this and write 5x plus y equal to 0, and I'll have x plus 6y plus z equals minus 10.5, and then I have y plus 7z equal to 25.5. I have reordered it in this way. I've made a conscious decision. Either I'm speaking too fast or writing too fast because people don't seem to be able to catch it. I promise I'll give you time. Just want you to listen. I've consciously written it this way, where if this coefficient of x or this coefficient for y or this for z, these coefficients are given a special name A11, A22, 833 are called pivots. And those pivots should not be zero. That's the first requirement. So A11, A22, A33 should not be equal to zero. Not only that, we want the pivots to be numerically greater than or equal to the sum of the magnitude of the other two. This is a requirement for the method to work. Okay. Why would you think that would be necessary? Why? Why should this be true for the method to work? Look at those three equations and look at the condition that I'm writing down, and can you connect the two dots? Can you connect the dots? Try. This has to be true for the method to work. Why? I can say the answer, but it wouldn't be as fun. That's why I'm asking you to think of it. So look at x. X is B1 divided by A11 minus A12 divided by A11 times y minus A13 divided by A11 times b. Okay. When you do iteration, what happens? You compute, you start with a guess value for y and z. You will compute this. If this number were less than 1, and if this number were less than 1, what would happen? And if this number were greater than 1, and if this number were greater than 1, what would happen? Think of this scenario, greater than 1. Suppose this number is greater than 1. You are having a x, which is a finite number. So this is like a finite number. And then this whole thing, you can look at it as a correction. If your ratios are greater than 1, what happens is that your correction keeps increasing in magnitude as iterations go by. So this correction will keep getting bigger and bigger and bigger, because think what happens. This number is greater than 1, whatever y is, it would be amplified, which will make x bigger, which will make y bigger, which will make x bigger, and it keeps on getting bigger and bigger. Eventually, all your x, y, and z will run towards infinity. They all keep getting bigger and bigger without limit. But if this ratio is less than 1, whatever your y is, its value is diminished, and as iterations pass, it gets even smaller. The correction eventually becomes 0, so you don't have to keep correcting. Okay, so two of the requirements for this method to work is that first you have to rearrange the equations such that the pivots are not 0. Pivot meaning the coefficients that multiply with, if you're going to use this equation to invert x, x has to be in that equation, right? That's kind of obvious. Then you have to rearrange them such that the magnitude of the pivot is greater than the sum of the magnitude of the other two coefficients. So in this case, 5 is greater than 1 plus 0, 6 is greater than 1 plus 1, 7 is greater than 0 plus 1. So it all checks out. So this will work this time. We will do one case where we intentionally goof it up and see how bad it can go. Okay, when we do Excel. Are we together? You okay? Good. So now I want you to start doing the iterations. So here are your three equations. Remember in the exam or in your work or whatever, three equations will present in some arbitrary order. The moment you see it, if you start applying Gauss seidel without thinking about it, you will be in trouble. You need to first think about this the pivot and then rearrange them and then proceed. Maybe not in your work, but definitely in the exam, I'll try to trap you. So look out. Okay. All right. So can you now start iterating? I'm going to fill out a table and you are going to enter the values. Okay. Wait, did you write this down? Did you write this down? You want me to write it again? Did anyone miss it? Sort of important thing. Okay. Can I erase this part? Okay, I'll wait. Are we good, Mary? Good. Can I erase this, everyone? As we do, try to form a table. Okay. So I have iteration number. I call it I. I have xi, yi, ci, and then I have a residue of x, which is defined as xi plus 1 minus xi, residue of y defined as yi plus 1 minus yi, residue of z defined as zi plus 1 minus zi. For the first iteration, which is our guess, we'll call it iteration 0. We'll guess 0, 0. Okay. So take your first equation. 1, 2, 3. Equation 1 gives you x equals 0 minus y divided by 5, or simply minus y over 5. Equation 2 gives you y equals minus 10.5 minus x minus z divided by 6. And equation 3 gives you z equals 25.5 minus y divided by 5. Okay, so for the guess or the 0th iteration, there is no residue. I'll put a dash. Okay. For the first iteration, I have my guess values ready. I need to take my equation for x, plug in these values, and get x. Y is 0, so xi is 0. Or x1 is 0. What is y1? What is what should I get y as? I should take the latest available values of x and z in order to compute y using equation 2. So that would be y1 equal to minus 10.5 minus 0 divided by 6, which is 1 minus 1, 45, that is 7, 5, minus 1.75. keep your calculator out. I'm going to need help. So what is Z1? How do you fill out this box or this spot? You'll take the latest available values of X and Y to compute Z, right? So go use equation 3. X doesn't appear here, but Y appears. So you would have Z1 equal to 25.5 plus 1.75 divided by 5. Can you tell me? 5.45. 5.45. So you've updated the values of X, Y, and Z once for all three of them. Now you can compute what is the value or what is the increase, the change in magnitude between this iteration and the previous iteration, which is for X that will be 0, 0 minus 0. For Y that would be 1.75 because we are dealing only in magnitudes. And for Z that would be 5.45.
The residues in this case, or how far you are from the actual value of X, Y, and Z?
No, residue is essentially measuring how far you are from prior iteration. As your values converge to something, these values will stop changing at all. Like they'll become very small, like close to 0. And you can set a tolerance and then stop based on. So when you do the next iteration, you will see that this minus 1.75, it went from 0 to minus 1.75, right? The next iteration may not be this big a jump, might be a smaller jump, then smaller.
So when that gets close to 0, you know you're close, your X, Y, and Z.
Yep. Yep. When each of these Rx, Ry, and Rz approach 0, you can say that you are getting closer to a converged solution. So you do the next iteration and then look up. Let's all do this independently and then look up. I could be wrong, like in making these arithmetic calculations. So yeah, what are you getting?
I think for the Y two, it's supposed to be negative 10.5 minus.
Yeah,
Okay, never mind.
Z value is 5.0.
It's fine.
You're getting this, all 6 values? Yeah, okay. So if you got this independently, congratulations. You now know the Gauss seidel method. Yeah,
Is that a 7Z?
yeah, 7Z, I cluttered it by each. Why?
So would it be, for this,
Oh, it's 7Z,
so that Z would be that divided by 7, not 5.
or 7 or 5, let me check. Y plus 7Z. So I cluttered it up. This is 7Z. So I would have to write this is 7. And this is 7. Did it have an impact in the previous round? Did it?
Yeah. Variable Z.
Okay. So why don't we just start over, do the 2 iterations and then go try. Okay. Simpler to do this again. So I have x1 is 0, y1 is minus 10.5 by 6. And z 25.5. 1.75 divided by 7. 3.8929. Are you getting? So I will recommend maintaining 4 decimal points and then in the end worry about how many significant figures are being asked. Look up for a second, all of you, please. So I have written very curiously 0 without any decimal point, and then minus 1.75 with only 2 decimal points, and then 3.8929 rounded off to 4 decimal points. What is the difference between these 3? I'm asking you.
I can get like the decimal points. Why?
The way I've written them, those 3 ways of writing them represent 3 different things. Are you seeing them as 3 things, or for you, you don't know or you don't see the difference? When we chose a guess value as 0, we are choosing a pure number called 0. We are not choosing 0.01 or 0.0001 anything. We exactly chose 0. How much precision do you have in a number which is a pure number? You would have infinite precision because the number is fully defined or fully prescribed just by writing 1 digit. It's a pure number. So when you do this calculation here, when you do this calculation, for example, if you take minus 10.5 minus 0 divided by 6, this is exactly minus 1.75. There are no more digits. This is, if you multiply these two, you will get exactly minus 10.5. Okay, that is why we are writing it with only 2 decimal points. There is no meaning to writing it as 1.7500 because it is only minus 1.75. When you do this calculation, for example, with this 25.5 minus y value being 1.75 divided by 7, what is your calculator actually reading out to you? Mine is reading 3.89285711429. Well, just how much numbers or digits this calculator can hold, but in reality, this is representing some physical quantity. You can't have infinite precision in that physical quantity. That's why you just cut it off at 4 decimal points and write it this way. So when I say express your answer to 4 decimal points, it's okay to do this. But when I say express your answer to 4 significant figures, how will you present this number? Express this number to 4 significant figures.
3.893.
3.893, that is 4 significant figures. Just for argument's sake, if this number is 39.8929, and I ask you, present this answer to 4 significant figures, what will your answer be?
13.90.
13.90, right? That is 4 significant figures. What if I ask you to present this to 3 significant figures?
13.9.
13.9. 2 significant figures.
14.
14. 1 significant figure.
Yeah.
It's a judgment call, especially in those cases which are on the fence. So 14 is like 10. If you are handling a lot of numbers and let's say you get a 14, we can say it's 10 to 1 significant. If it were 19, you would have called 20. So know the difference between number of decimal points and number of significant figures. They represent 2 different things. Okay. And then there are pure numbers. And then there are exact rational numbers. Okay. So that it's essentially the difference is between pure numbers, rational numbers, which are exact multiples, or at least they have a quotient which has limited precision, and then there are irrational numbers. So anything divided by 7, kind of like pi, those kind of things have a lot of digits. Okay, it's a small sidebar, but I thought it's a useful thing to know. Okay, so then what are our residues or Rx, Ry, Rz? 0, 1.75, 3.8929. Let's do one more iteration, please. X2 will be 1.75 by 5, 0.35. Again, 0.35, I'm writing it only 2 decimal points. Y minus 10.5 minus 0.35 minus Z is 3.8929 divided by 6. Minus 2.4572. Z value 25.5 plus 2.4572 divided by 7. $3.9939. So what is our residues? 0.35. 0.7072. This is 3.8929 minus 99. 0.1010. You're okay? Shall we do one more iteration before we jump to Excel? Because once we figure out something, we get lazy and automate. That's what we do. Iteration 3. Is everyone okay up to here? These 6 numbers you are able to get? We all agree? Okay. X3 is is 2.4572 divided by 5, which is, I can do this by 0.4916. 0.4916. Y3. Tell me if I'm wrong, okay, please. Two point four nine minus 2.4976, and C3 is 25.5 plus 2.4976 divided by 7. Three point 9997. Are you getting these numbers? Yeah? Santiago? Yeah? Parker, right? Yeah. Are we now clear enough that we are comfortable to automate this using Excel? Or do you want to do one more iteration? Let's do one more, because in the exam, you'll be asked to do either 4 iterations or until a residue condition is satisfied. So let's do one more iteration. Iteration 4. If you got this and you feel bored, that's actually a good sign. X4 is 2.4976 divided by 5. Point 4995. Then Y4 is Z is 3.9997 divided by minus 2.4999, and Z equals 25.5 plus 2.4999 divided by 7. It's rounding out to 4.0000. Why am I asking you to maintain 4 decimal points in intermediate calculation? Because I just say so and you have to follow. Yeah, because I say so. Yeah, isn't there any reason for me for saying so? When your parents say something and say, do it because I say so, you really think they are just making you do things or they have a reason to say whatever they say. The reason we are sticking to 4 decimal points is because if you round off to, let's say, only 1 decimal point, the amount of round off error will keep accumulating in each step, keeps going up. If you want to maintain a good accuracy in your calculations, you want to keep as many number of decimal points in intermediate steps, but finally you have to round off correctly. So I suggest 4 decimal points regardless of what the final requirement. Okay, finally you round off as needed. Okay, 4 is the standard that I recommend. Okay, so you look at this column, the 3 residues, you see how it was initially high and then it's becoming very small. If you keep doing more iterations, you can see that this iteration is after a while not necessary because the residues have nearly become 0 and there is no use in doing more iterations. RZ has already almost converged and R2, RY and RX are still on the way. So maybe if you do 1 or 2 more iterations, all of them will become small. You could have a condition like saying if RX or RY or RZ are greater than the tolerance, you can keep continuing, if not stop. Or you could say Rx squared plus Ry squared plus Rz squared square root. If this is greater than tolerance, continue, otherwise stop. You could do it either way. There is no like universal rule about doing one or the other. This is simpler. This is like having a few or statements or if statements. Okay. Are we good so far? Shall we try this in Excel? Okay, same problem. We are going to try in Excel. Okay, please open your Excel and we'll build this together. I have something built from last time or last year, but I will start again. Okay. So before you do, kindly pay attention here. This is from the previous time, but what you have is first I have the coefficient matrix. I've labeled everything. And then I have my x, y, and z, which I call here x1, x2, x3. And then the residue rx, ry, rz, they are here. And then I have a continue or stop statement written here so that you can automate the stopping criterion. So I'm going to do this thing from scratch. Okay, so let's start here. You want to first enter your coefficients A11, A21, A31, A11, A12, A13. Here's your matrix, okay? So this would be A31, A32, A33. For our system of equations, what would be these values? It's behind the board here. So look at your first equation, which is 5x plus y equal to 0. What is A11? Okay, I need one of you to tell me the equation so I can write it here. All right. 5x plus y equal to 0. What is the second equation? X plus 6y
But the
plus z equals
negative 10.
negative 10.5. And third equation is
Y plus 7z.
thank you 25.5. Okay, so what will my A11 be? 5. A12 is 1. A13 is 0. Type it in. So if I interact with the background, this writing goes away. Okay, but I'm going to write this is 5, this is 1, this is 0. And then I'll have one more column B1, B2, B3. What was on the right side? Oh, this 0. Okay. Zero. Okay. Okay, this annotation tool is sort of annoying. I'm going to stop annotating. All right. What is the next equation? X plus 6y plus z equals minus 10.5. Then A21 is 1, A22 is 6, A23 is 1, and then this is minus 10.5. And the third equation is y plus 7z equals 25.5. 0, y plus 7z equals 25.5. Tell me if you are able to you follow this step. That is, you are able to take a system of equations and write them out in this form. Okay. All right. What is the next step then? Form our table, right? So we'll say iteration number x I, y I, z I, and then I'll write rx, ry, rz. Mary, do you have any question? You're not going to try this? No power? Okay, iteration 0, my guess value, okay? Guess. I'm going to guess 0, 0, 0. There is nothing that prevents you from guessing 0, 0, 0. You can guess any value that you want, doesn't matter. First iteration. What is the point of doing this in Excel? Automation. So you want to punch in not the value, but the formula. So you want to type in this formula, okay, with B1, A1, etc. They are all given by this table here. So you want to write the X value is B1, which is here, Once you select B1, press the F4 sign to get this double dollar sign. You know Excel, right? What does this do? It freezes the value of that cell so that when you drag it to the next cell, it still refers to E3 and not E4. F4, press F4. Select that cell E3 and then press F4, the two dollar signs will appear. So B1 minus A12 F4 times the latest value of Y minus A13 F4, the latest value of X, divided by A11 F4. I'm keeping it like this so that you will do and then we can go on. So I just did Y. I punched in a formula for Y, which involves A12, A13, A11, and B1. Now do the same thing for Y. Okay, I mean I just did for X, do it for Y. Equal to B2 F4 minus A21 F4 times the latest value of X minus A13 F4 times the latest value of Z divided by A22 F4. And then I'm going to go ahead and do the Z value as well. Okay, those who are trying, can you please tell me some feedback about whether you are able to implement this first iteration? If you need help, please tell me. Oops, sorry. If you get these three values highlighted here, you just basically got it. Question? How are we doing? Are you getting these three values? Yes, no, still working. Okay, Parker, you got it? Okay. Santiago, still working. You wired? Okay. This is what? Yes, it is being recorded. Okay, so if you did this right, all you have to do is drag it on to the next cell and you should get these values. So you can check if you got it right. It's not enough if you just got this one iteration. If you extend it to a second iteration, are you getting these values? That is the question. You got this? No?
This is messed up.
Please make your screen bigger. Okay, there. Okay. Thanks. Okay, so you go to your x. Okay, so what is x? It's equal to, you've done that. Okay, then so e. Yeah, exactly. Well, you can put the brackets or you can just put minus a1 2 times y. And I just, okay. When I did this in Excel, I just took this to be minus and this also to be minus. Okay. You need to first connect this formula with the table that you built here. If you are able to do that, you will be able to do the rest. If you're stuck, at least tell me so I can come and check what you're doing. Right now, I'm not getting any feedback. Are you able to get this? Get it? Okay. Are you? Okay. Need some help? Get the home. Okay. Yeah, let's do it. So, okay, yeah, try doing the successive iterations and see if you get those values. I'll give you like a, I mean, we are almost near the end of the class. I thought we could try one more example. So take a pause. Let me make a few remarks and we can wrap for today. Okay. So look up. You can then continue. There is still time left. So if you go through successive iterations, as you can see, we started with a guess value like 000 without thinking. As iterations go, the solutions converge to a particular value like here 0.5, minus 2.5 and 4. And more importantly, for these after 6 iterations, the residue values are almost below 10 power minus 5. Hello? Look up. The residue values are all below 10 power minus 5, which is what you get as decimal point followed by 4 zeros. So you could have a stopping criterion, which is just look at the residue values individually and say until all of them go below a certain value, you can keep iterating. Or you can say the sum of squares of this should go below a value and you can keep iterating. Either way is okay. I'll post this file. What you will also see is that last time when we tried this, we wrote an if statement. So if you see here at the top, we wrote an if statement saying if the residue is less than the tolerance, stop, otherwise continue. So it says continue, 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 and then after the fourth iteration, it says stop. So we had a criterion going on in this problem. So I'll post this as well, kindly review it. For your test, at least on Tuesday, it is going to be only pencil and paper. You will not have access to computer, no Excel. You have to do a hand calculation. And if you see the mock quiz, I have asked for solve the above system of equations using the Gauss-Seidel method. Perform 4 iterations or until the residue goes below a certain value, whichever happens earlier. And residue is calculated as this. All you have to do is to fill out this table, which is the same as what we did in the Excel sheet. Okay, so practice doing this for different set of equations. You can go to your textbook, pick any set of equations and try filling out this table. Okay. All right, good. So you can continue working on your Excel sheet. I have a last announcement for the day, which is I know fall is here and flu season, COVID season, every season is here. If at all you get sick, but you are still able to attend class, and if you let me know, I'll provide you the Teams link so you can join from home instead of losing class. But don't use this to just take a day off. I will only accept rare instances where you are actually sick, not like whenever you want. Okay, so be very judicious about it. So we'll meet on Tuesday. Your homework 1 is due and the quiz is on. Okay. All right. Thank you.